Hello everyone. In this video, you'll be learning about list of text nested data structure. This nested data structure also enables us to represent a table. Unlike lists of lists representation, the list of text representation is going to make it easier for us to perform the lookup operation. But list of text nested data structure is much slower when compared to list of lists nested data structure. Let's understand the list of text representation using an example. I have a simple table here where there are three columns, name, X and Y. We have three data rows, Alice, Bob and Cindy. On the left hand side we have the list of list representation for this table. You have header variable, which is a single dimensional list that is storing the column names as items. Then you have the rows variable, which is the list of list data structure. Each inner list is going to be one row within your table. Here is the corresponding list of dictionary representation. The outer data structure is going to be a list. The inner data structures will be dictionaries which represent rows. Each dictionary is going to have the column name as the key and the corresponding column value as the value. Let's go through an example lookup with both of these representations. Let's say that we are interested in looking up the value 50 here. With the list of lists representation, we'll have to say rows of 2 to get to the inner list which represents the Cindy row, and then we'll have to say header dot index of Y in order to look up the index corresponding to the column name Y for the second dimensional index here. Let's look at the corresponding lookup for list of text representation. We'll still have to say rows of 2 to get to the dictionary that represents the Cindy row, and then we can simply say of Y. That's because the second part within the square brackets here is performing dictionary key lookup for the key Y, and the corresponding value is going to be 50 here. We are going to go through a simple demo for this representation. We'll still be working with tornadoes.csv. We are going to take the list of lists representation, which is the output from process underscore csv function, and we are going to write a transform function which will convert the list of list data structure into a list of dictionary data structure. Let me switch over to my Jupyter Notebook session. At this point, I want to mention one quick thing about file processing. You should not be calling process underscore CSV function over and over again to read the data from files. That's because file processing is terribly slow. Instead, once you call the process underscore CSV function, you will have to work with the variables which are storing the data using the data structure within your program. So I'm going to make use of header and rows variable which we have already initialized at the top of the notebook. Let me scroll down to the bottom of the notebook. Let me start defining the transform function. The two parameters are going to be header and rows. Within the transform function, I'm going to write for loop to iterate over every row. So I'm going to say for row in rows. For now, let me just display rows. I'm going to call the transform function by passing header and rows as argument, and then we can verify whether the for loop is working correctly, which seems to be the case. Let's think about what we want to do here. We want to take every row within the list of list data structure and convert that into a dictionary, correct? So where do you have to define your list for your list of dictionary data structure? Think very carefully about that. You want to create the list outside the for loop because the for loop is iterating over every row in your list of lists representation, correct? So I'm going to define a variable called dict underscore list. You can think of defining a more meaningful variable name once you work with real data, or let me right away change that. I'm going to say tornadoes underscore list here. All right, so within every iteration of your for loop, you want to be able to create a new dictionary to represent that particular row, correct? So I'll have to define a new dictionary by saying new underscore row equal to open curly braces, close curly braces. We'll have to write another for loop to iterate over every item as part of the row in order to be able to add those as key value pairs with the new underscore row dictionary here. So I'm going to write an index based for loop for that, because we are going to use the header to look up the corresponding column value. So I'm going to say for index in range of len of header. It does not matter if we say header or row here, both of those will have the same number of items. What do we have to say to populate the new row dictionary here? We'll have to say new underscore row square brackets of key equal to some value. What's going to be the key? That's going to be the column name. How do we get the column name? We'll have to say header of index. What's going to be the value? That's going to be the corresponding data value within row variable here. So we'll have to say row of index here. After populating all of the key value pairs within the dictionary, which will happen once you go through all the iterations of the inner for loop, what do you want to do with the dictionary? You want to be able to append that into tornadoes list, correct? So I'm going to say tornadoes list dot append of new underscore row here, and then I'm going to return tornadoes underscore list from the function. So let me go ahead and execute the function definition and the function call. Looks like we are getting the list of dictionary representation here. Let me capture the return value into a variable called transformed underscore data. I'm going to use transform data to go through lookup examples. First of all, I want to extract row number 0. I can do that by saying transformed underscore data of 0. Observe that we are getting a dictionary here. What if we want to get the year column value? We can simply do that by saying transformed underscore data of 0 of year. And instead of year, if we want the location, we can just replace the second lookup with location. Let me quickly switch back to the slide deck. I'll not be going through the slides about the dictionary of dictionary representation. The dictionary of dictionary nested data structure enables us to perform counting based operations. That's very powerful when it comes to any applications which require you to keep track of counting. The dictionary of dictionary representation is also helpful for representing something which is called as sparse tables. I'll talk about what is meant by sparse tables as part of the next lecture. Feel free to go through the slide deck about dictionary of dictionary representation on your own. I've decided to leave the slides in so that there'll be interested students who go through this particular section of the slide deck. You will not be tested with respect to this portion of the slide deck as part of quizzes or exams. That will be it for today's lecture.